Okay, welcome to the Unit 3 review session. Again, one more time, remember that I do not have the capability to actually write on the review, so I actually have to reference the review and then do the problem on the actual smart notebook. I want to go ahead and just let you know which numbers we'll be doing. I'll be doing 1, 3, 5, 7, 10, 12, 14, 17, 19, 21, 24, 25, 27, 29, 31, 33, 35, 36, 39, 41, 43, 45, 47, and 49, and 51. Let's go ahead and get started with number 1. As you see on number 1, it says all real numbers greater than or equal to 70. They're looking to find out what inequality represents that expression. So over here on my smartboard, I'm just going to tell you that it's x is greater than or equal to 70. That's how you do that problem. That was number 1. Okay, if you look at number 2 or number 3, they're looking for how to solve this, or which one is a solution. So you need to add 11 to both sides of the inequality, and you get 8x is greater than or equal to 23. To solve it, I then divide by 8 on both sides because it's 8 times x, and I get x is greater than, I believe it's 2.82 or something along those lines, but 23 over 8 is an actual solution, so that's choice D. Okay, number 5 at this point is c minus 5 is greater than 6. You need to solve it and graph it. Add 5, add 5. You then get c is greater than 11. That's my inequality. To graph it, go ahead and put 11, 12, 13, even put a 10 here. What I can then do is put an open circle at 11 and then go in the positive direction. And again, if you write it in the correct way, it actually points in the right direction. See, this greater than points to the right. For number 7, it says, suppose you had D dollars in your bank account. You spent $13, but you have at least $29 left. How much money did you have initially? Write and solve an inequality that best represents the situation. So D dollars, going to go ahead and start with D. You spent 13. When you see the word spent, you should be thinking I subtract 13, and I have at least, meaning greater than or equal to 29. So that's my inequality. Okay, that would be my inequality. I then need to go ahead and solve that inequality. So I add 13 to both sides, and I get D is greater than or equal to 42. And so I had at least $42. Number 10, I have to solve the inequality and graph the inequality. So I subtract 4 from both sides because it's the opposite operation. So I get h is greater than -1. That's my solution. I then go ahead and do my quick number line. So I get -1, 0, 1, and 2. Oops, I tend to do that. Let's put my 2 on the number line. Here's -2. So to graph this, I need to go ahead and put an open circle around -1 and go to the right, meaning greater than. For number 12, I have negative x over 3 is less than or equal to -1. To solve this, I need to go ahead and multiply both sides by -3. The -3's cancel out. And then multiply the other side by -3. And what I get is I get x all by itself is 3 on this side. And because I multiplied by this negative number right here, I then get to switch the inequality symbol, and then I get to graph. So here's my graph. Put a filled-in circle at 3, and then go in the positive direction. Okay, number 14. On your paper, you should see the French Club is sponsoring a bake sale. If their goal is to raise at least $130, so you should be thinking at least $130. How many pastries must they sell at $2.50 each in order to meet their goal? Okay, sorry, I had somebody come in the room there. So at least $130 is greater than or equal to 130. How must they sell? How many pastries must they sell at $2.50 each? So when you think of $2.50 each, you think $2.50 times x is greater than or equal to 130. So then to solve that, this is your inequality. To solve that, you then would divide by 250 on both sides, and you would get x is greater than or equal to 52 pastries. So I believe in the context of the question, you must sell at least 52 pastries. Number 17, you have to find out what are the solutions of this inequality, and then you have to graph it. So first of all, I need to multiply both sides by 6, okay, because it's divided by 6. Those 6's cancel out, and I'm left with x is greater than or equal to negative 24, and then I need to go ahead and graph it. So I get negative 24, negative 25. Make sure I know what direction you know you're going in. And I put a closed circle at negative 24, and I go in the positive direction. Okay, for number 19, you have 9x is minus 5 is greater than or equal to 4. It says in set builder notation, how do you write the solutions of the inequality? First of all, you got to go ahead and solve it. So I have to add 5 to both sides. This should be automatic by now. I then have 9x is greater than or equal to 9. And then I divide by 9 on both sides. And I get x is greater than or equal to 1. But that's not my final answer. I need to figure out in set builder notation how to write that out. First of all, you need your little bracket. Then you got to define a variable, so we'll call it x, such that x is greater than or equal to 1. And then end your bracket. And that's how you do it in set builder notation. For number 21, you have a set negative 5 and 8. It says, what are all the subsets of that set? Well, first of all, you could have just a null set, or you could have, this is also a null set. You could have just negative 5. You could have just 8, or you could have negative 5 and 8. Those are all the subsets. All the different combinations. All right, number 24, it says D is the subset of all whole numbers less than 5. It says, how do you write it, or how do you write the set in roster form and also in set builder notation? So first of all, in roster form, let's just list out what numbers those are. So whole numbers have to be non-negative, so they have to be 0, 1, 2, etc. So starting with 0, I still have 1, that's less than 5. 2 is less than 5. 3 is less than 5. 4 is less than 5. And it does say less than 5, not less than or equal to 5, so we can go ahead and stop there. So this is actually roster form. So that's roster form. That's my one answer for roster form. Then in set builder notation, I go ahead and say I have a variable x such that x is a whole number. That's the first criteria. And I'll use my little number symbol. Whole number, put a little comma, and we have to define that x must be less than 5. So you're saying it must be a whole number, and then it also must be less than 5. So that would be your set builder notation. So that's set builder. So both of these are actually your official answer. Number 25, you have a compound inequality. You want to figure out what is the solution and go ahead and graph it. First of all, you have a compound inequality here. So normally, to get x by itself, which you're still going to do, you'd add 4 to both sides of the inequality. But there's two different inequality symbols. I want you to notice that. So I not only have to add 4 to the right side, I actually also have to add 4 to the left side. So in the middle, negative 4 and 4 cancel out. On the right, I'm left with 8. I keep my symbol. I drop down my 2x. I keep this symbol. And I'm left with negative 2 on the left. So already it's much, much simpler. I still, again, have this x in the middle that I need to get by itself. So I see 2 times x. So I need to divide all sides by 2. So not just the right side, but also the left side. So this cancels out. And I'm left with x in the middle. Keep this symbol. And you get negative 1 over here. Nothing flips yet. And then 8 over 2 is 4 on this side. So you have negative 1 is less than or equal to x is less than 4. So it's better read as x is between negative 1 and 4. And negative 1 is actually included. So there's your solution let's go ahead and graph it. And first of all, I need to have like -2, -1, 0, 1, 2, 3, 4, and 5 maybe, just so I know that you know what you're talking about. And what I need to do is go ahead and write out, okay, well I know -1 has to be included because it's or equal to. I know that 4 is not included because it's not or equal to. And I know that x has to be between those two things. So I go ahead and graph and I fill in between those two things. That's my answer. Okay, at number 27, it gives you x is greater than or equal to -7, and it gives you x is less than 8. And it says, how do you write those in interval notation? So first of all, let me just go ahead and graph them. I want to know what these actually are representing. So it's greater than or equal to -7. So I go ahead and graph that. It's got to be included as -7. I then scribble to the right because it's greater than that. So it's everything to the right. And then I have x is less than 8. So I open the circle at 8. And now I go in the leftwards direction. Okay. So what I want you guys to notice is this section right here. Because that's the section that's covered over by both of them. So that's what we're trying to represent by our interval between -7 and 8, and -7 is included and 8 is not. So how you actually write that is, if you want to include something, you put a bracket around. So I have -7, that's for my bracket, that's including -7, and 8, but 8 is not included, so you put an open parentheses over top of it. That's how you actually write that in interval notation. Number 29 asks us to find what the solutions are and to also graph it. And what I need to do first of all is I need to realize it's an absolute value equation. And I need to move everything over that I possibly can and try to get just an absolute value all by itself. So I get 8 absolute value n, 8 times the absolute value of n, equals 16. A little bit better. I then see 8 times the absolute value of n, so I need to divide by 8 on both sides. I then get this to cross out. I get absolute value of n equals 2. What this means is I could have 2, like the absolute value of 2 equal to 2, and I could have the absolute value of -2 equal to 2. So what I can do at this point, when you just have a clean absolute value equation, I can break it up into n equals 2 and n equals -2 and continue to solve it, but n is actually by itself in both of them, so I'm actually pretty much done. So now I graph it. Go ahead and put your numbers on. So 0, 1, 2, and just represent where those are. So -2, dot at -2, 2, dot at 2. There is no arrows, nothing. Those are just those two solutions. Okay, 31, same thing. It asks you to find the solutions and to graph it. But this one is an absolute value inequality. First of all, realize that what they're asking is the solutions of this are at least 7 units away from 0. So it's got to be farther than 7, and it's got to be farther than -7 away on the number line. So what I need to do right off the bat, since I have just a clean absolute value equal to or greater than or equal to something, I can go ahead and split it up into d plus 2 is greater than or equal to 7, or, that's the key word, or, d plus 2 is less than or equal to -7. So that's what I'm trying to say. It's going to be farther away than 7 or farther away than -7. So I need to go ahead and solve both of them. So I have -2, subtract 2 from both sides, and I then get d is greater than or equal to 5. So it's going to be farther than 5 units away. And then I also have to subtract 2 from both sides over here, and I get d is less than or equal to -9. So that's or in between. So that's any and all. So then I go ahead and I do my inequality, or my number line, and you can go ahead and shorthand some stuff. So I have -9 and -8, and we'll go dot 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 dot, 0 in the middle, and then you pick up at 4 and 5 and 6 just to represent this. So what I then do is I need to go ahead and say, okay, I need to go greater than or equal to 5. That's to the right. And then need to go at -9, start at -9, and go less than. And that's my answer, because it's or. Okay, for number 33, it says the optimal operating temperature of a given car engine is within 5 degrees of 215 degrees. So when you see within 5 degrees, you should be thinking less than or equal to 5. So it's within 5 degrees. Now the absolute value piece is a little bit tricky. I'm just going to go ahead and guide you through it. You start with your x, and then you'd subtract that 215 degrees that you see. That's actually your absolute value inequality to represent the range of acceptable temperatures. So now what I need to do is go ahead again and split it up into my two-sided inequality. And so what I do is I then have x minus 15, or 215, and this is one where it means it's less than 5 units away from the number line. So this is where you leave your less than or equal to 5 on the right-hand side, but you also make sure that it's greater than negative 5 on the left side. So now what I need to do is go ahead and add 215 to both sides. Cross it out. And I get 210 is less than or equal to x is less than or equal to 220. So what does that mean? Well, the original problem says you need to find the range of acceptable temperatures. So what that means is I've got to be between 210 and 220. On number 35, they give you quite a bit of information before that. It says x is a whole number less than 15. So what I did was I went ahead and I listed out all of the numbers less than 15 so I knew what they were. Then also for y, it says y is a multiple of 3. So I went ahead and did all the multiples of 3. Okay. I then look at my problem and it says, what is the intersection? This means intersection right there. It's upside down U. It's intersection. What is the intersection of x and y? Well, it simply means all the numbers that are the same in both. So let me just show you by circling them. What are the numbers that are the same in both? I have 0 is common in both. 3 is common in both. That means it's the intersection. I also have, let's see, 6 is common in both. And I also have 9 is common in both. And I also have 12 is common in both. But if you notice, it stops there because 15 is not included in x, but it is in y, and nothing bigger will work. So my official answer is I have a set here, with it, which is the intersection. X intersection of y equals 0, 3, 6, 9, and 12. That is the intersection of those two. If it had been the union, you'd be writing everything down. Number 36, I'm going to go kind of fast on. It says of 360 consumers polled, some purchase music on CDs, some only download music, and some do both. If 260 people polled purchase CDs and 200 people purchase CDs and download music, how many people download music total? So what you need to do is take the number of people polled that purchase CDs, which is 260, and minus the people that purchase CDs and download music, which is 200, and add a missing value, which is how many people download music, as x, and set it equal to your total people polled, which is 360. Then you simply have to solve this equation. So 260 minus 200, I combine like terms, give you 60, plus x equals 360. I then have to subtract 60 from both sides, and I get x is equal to 300. So 300 people download music. Alright, 39. 39 says, what are the solutions of absolute value of 2x plus 10 is less than or equal to 6? I need to go ahead and split this up by writing out my 2x plus 10 is less than or equal to 6, and I also need to make sure it's greater than or equal to negative 6. So what I can do right here is I can subtract 10 from both sides, from all sides actually, and then I get negative 16 is less than or equal to 2x is less than or equal to negative 4, and I can then divide by 2 on all sides, and I get, that crosses out, I get negative 8 is less than or equal to x is less than or equal to negative 2. So it's x is between negative 8 and negative 2. And so what I need to do then is go ahead and write this out as the union of two, either the union or intersection of two sets. And what I'm going to do is I'm going to write it actually as the intersection. So this is a partial answer. This is a good start. But now I need to go ahead and write it in set builder notation, which I have x such that x is less than or equal to negative 2. That's this piece. Okay, and then intersect it with x such that x is greater than or equal to negative 8, which is this piece. So that's why it's the intersection. It's a little bit complicated, but the more and more you practice these, the better you'll get. Okay, 41. The bulk food section of a grocery store has two bins with different types of mixed nuts. The first bin contains walnuts, peanuts, pistachios. Alright. And the second bin contains pecans, almonds, Brazil nuts, and I already listed walnuts, so I'm not going to list it. Now, it just so happens that they wanted us to represent all the types of nuts in both bins. So that would be the union. So this is, I literally just listed them all out and didn't repeat the pecans, or I'm sorry, the walnuts. For number 43, they ask you to solve it and graph it. I see negative 2 times c, so I need to divide by negative 2. And careful with that one, because when you divide by a negative number, the inequality symbol flips, and you're left with c is greater than 7, not less than 7. And I need to go ahead and graph it. So I have 6, 7, 8, 9, open circle at 7, going in the positive greater than direction. Number 45, they want to find out what the solutions are, so we need to go ahead and solve it. And if you go through your steps, clear fractions, there are no fractions. I then need to distribute. I absolutely need to distribute. I get 10 on the left side plus 15g is greater than or equal to 10 times g, 10g. 10 times 10, 100, so I put plus 100. Now, I go about combining like terms on the left side. So 10 plus 15g, those cannot be combined. On the right side, 10g and 100, those cannot be combined. So, but what I can do is realize that this 10g is not on the same side as this 15g, so I want to go ahead and move it. And how I do that is I subtract 10g from both sides, because currently it was positive. And so what I get then is I get 10 plus 5g is greater than or equal to 100. Now, I'm still solving for my g here, so I subtract 10 to get that out of the way, and I get 5g is greater than or equal to 90. And then I divide by 5, and I get g is greater than or equal to 18. And that's your answer. Okay, number 47, it says U is the universal set. That's what you're starting with. Is negative 9, negative 7, negative 6, negative 4, 1, and 8. And they tell you that T is a part of that, which happens to be negative 9, negative 7, and negative 4. So you used, just kind of making a mental note, I used negative 9, I used negative 7, and I used negative 4. So it says, what is the complement of T? That's all the ones that were not included in that. It's all the numbers that I just circled. So you'd represent that as T prime, or the complement of T, is equal to negative 6, 1, and 8. And that would be your answer. That's what the complement is. Number 49 says, what compound inequality represents the phrase, and graph it. It says all real numbers that are greater than negative 2 and less than positive 2. So you put your x in the middle. You want that to be greater than negative 2 and less than positive 2. So it's x is between negative 2 and 2, or bigger than negative 2 and smaller than positive 2. And so then I need to go ahead and graph. So I put negative 2, negative 1, 0, 1, 2. We'll even put a 3 and a negative 3. Put your open circle at negative 2, open circle at 2, because it's not included those. Does not include those. And I scribble in between them. That's in between the negative 2 and 2. Number 51, last question, last type of question, is 8x minus 4 is less than negative 12, or 8x plus 6 is greater than 14. They want to know what are the solutions and graph them. And with these, you just simply solve both of them side by side. So you add 4 to both sides, and you get 8x is less than, that would be negative 8, sorry. And then I divide both sides by 8 for this one. And I get x is less than negative 1. Does not flip, okay, because you're not dividing on the bottom by a negative number. Over here, I subtract 6, and I get 8x is greater than, that ends up being 8. So then what I do is I divide by positive 8, this is multiplied by 8, and I get x is greater than 1. And so what I have here is I have two different inequalities. I'm going to try to put them on the same graph. Negative 2, negative 1, 0, 1, and 2. We'll even do a 3. And first of all, over here, x is less than negative 1. X is less than negative 1 is an open circle and then shaded to the left because it's in the negative direction. Over here, x is greater than 1 ends up being an open circle again and to the right. And so that is my solution. Okay, this has been the review. If you have further questions, obviously we will have lots of time in class and lots of question and answer time in class. We also have a review answer key that gives you step-by-step solutions and explanations to each question, so you have every excuse to possibly pass. Good luck on your test.